I am delighted today to welcome you to our today's class, being on 8th of January, the year 2025. And I have a question in A level of our Cambridge GCSE curriculum. And the question reads, the coefficient of x cubed in 3 plus ax raised to 6 is 160. They are saying the coefficient. A coefficient is a value which is numeral that tends to appear before a particular letter or group of letters in a particular algebraic expression. So the coefficient of x cubic in 3 plus ax raised to 6 is 160. So the question says, find the value of a. You have been told to find the value of a. So we will be able to actually carry out this expansion up to this term that has x, which is raised to 3, or that has x cubic. So I'm going to begin from this end. If this is my expression that needs to get expanded to this level, then that means I'm supposed to first begin by having this 3 raised to 6. And of course, in terms of what we have as binomial expansion, we always tend to have this first part of that expression getting raised to the highest power that we're supposed to use in our expansion. Then this second part of that expression has to get raised to the lowest power. So I'm going to have ax getting raised to 0. Forget about the plus, combine them and make them to be one part. So then I'm going to have plus, again 3 raised to 5, in that decreasing manner, in as far as the first part is concerned, and in that increasing manner, in as far as the second part of that expansion is concerned. So I'm going to have ax raised to 1. Then I'm going to say plus, the third part is going to have 3 raised to 4 and ax raised to 2. So that if I come back here, I know the power that I'm going to use in my expansion is 6. So then that means 6 plus 0 must give me 6. So the two powers to which you're actually using in this expansion are supposed to add up to this value. On this other end, I'm actually having here 1 and then 5 here. So I need to say 5 as my first power and 1 as my second power, and that gives me 6 as well. I have 4 and 2. That gives me 6 as well. And then I'll say plus, okay, 3 raised to 3, then ax is raised to 3. You see, they told us that our expansion up to where we are supposed to stop should be able to have x raised to 3. This is going to have x raised to 0. This will have x raised to 1. This will have x raised to 2. But this is going to have x raised to 3. So we are going to stop here. Okay. As we proceed forward, we are going to have this. 3 raised to 6 is 729. Okay? And of course, this part raised to 0 is 1. So it gets dropped in that case. And I'll say plus 3 raised to 5 is 243. Then I'll have a raised to 1, that is going to be a. Then x raised to 1 is going to be x. Then I'll say plus. I'll come here. 3 raised to 4, that is going to give us 81. Then a raised to 2, that will be a squared. Then x raised to 2 will be x squared. Then we shall say plus. And the last part, 3 raised to 3, is going to be 27. Then we shall have a raised to 3, that will be a cubic. Then x raised to 3 will be x cubic. Okay. And that That is our expansion. Whatever remains is looking for the binomial coefficients of 6. We always get these values from what we call a Pascal's triangle. And those values are supposed to be, let me just write them down. I'm going to have 1, okay, that is 6, 15, 20, 15, 6, and then 1. Those are the binomial coefficients of 6. You see, these are normally given in any examination that a student is given, just in case there's a question that talks about an expansion. So these are the binomial coefficients of 6. They are going to be plugged into this expansion to make our expansion very effective and successful in terms of getting the answer. So I'll just pick the first expansion in terms of what we have as our coefficient and put it here. I'll pick the second, which is 6. I'll pick the third, which is 15. I'll pick the fourth, which is 20. Then, so I have 1, 6, 15, and 20. These have no use. Why? Because our expansion has actually gone up to x power 3. So we've stopped here. So you can be able to work out further and be able to get the final answer in as far as this question is concerned. So where did I get my calculator? Okay. So this is our calculator. So we have 1 times 729, that gives us 729 plus 6 times 243, so 243 times 6, that gives us 1458, 4,000. And that gives us AX. Okay, so we shall say plus, so we shall have 81 times 15, that gives us 1215. So 1215 s squared x cubic, and that is now square. So the last part has the cubic part. So you're going to say 20 times 27, that is 540. So we shall be able to have 540 a cubic x cubic. And because the question says the coefficient of x cubic, which is now this, so that means the whole of this part serves as the coefficient of x cubic, this whole part, because this is our x cubic. So the coefficient of x cubic, this whole part, is 160. And they're asking us to get the value of what? A. So we shall come down here and write 540 a cubic x cubic. We shall not use this, we shall not use this, we shall not use this. We are going to use this last part. Why? Because the question is so much centered on that part that has the x cubic. So they're telling us the coefficient, that part that just come somewhere close to x cubic, you see, is 160. So this whole part we are seeing here is what we refer to as the coefficient of x cubic. You see, and this whole part is equivalent to 160. So we need to ask ourselves, what should be the value of A, so that when we multiply with this 540 and end up serving as the coefficient of x cubic, should actually end up giving us 160. So what we do, we just take 540 a cubic should be equal to 160. We shall divide both sides by 540, divide both sides by 540, so that our a cubic should be equal to, we shall take 160, that's around 8 over 27, yeah? So we shall have 8 over 27. So I'm going to get the cube root on both sides so that I can get the exact value of a. So the cube root of a cubed is just a, the cube root of 8 is 2, and the cube root of 27 is 3. So that becomes the value of a. Thank you for your time and being part of our class, and we will meet in our next lesson.